So the problem here is let I is equal to integral 0 to 1 mod
Hello.
and yes, I can hear you.
Good afternoon, sir.
Good afternoon. 2 pi x dx. Okay, this is the problem. Now, first of all,
Okay, sir.
you see a 2 pi here. Okay, so what we assume here is that let t is equal to 2 pi x. That means dt dx is 2 pi. That means dx is dt by 2 pi. Okay. So therefore, what does integral change to? Therefore, I becomes, also we need to change the limits also. So let us evaluate the limits. What would the new limits will be by change of limits? For x is equal to 0, we have t is equal to 2 pi into 0, which is 0. And for x is equal to 1, you have t is equal to 2 pi into 1, which is 2 pi. Okay, so therefore the limits will change to 0 to 2 pi. Therefore, I is equal to integral 0 to 2 pi mod sine t, and dx is dt by 2 pi. Now, 1 by 2 pi is constant. You can take it out of the integral. Integral 0 to 2 pi mod sine t dt. Now, see, this in itself is a problem. Okay, this in itself has come. This integral you see here, this had come in your examination. Okay, I am showing you a
Okay.
little bit modified version of the problem, but this integral in itself has come in your examination. Okay, so how to evaluate this integral? Now, if you see, the limits are from 0 to 2 pi. Okay, now you see that we observe that sine t is equal to sine t for, in which quadrant sine is positive? First and second quadrant. That means for t lying between 0 and pi, right? Sine is sine t, and it is negative in the third and the fourth quadrant. So this is equal to minus sine t for lying between, let's say, yeah, this was okay, for t lying between pi and 2 pi, right?
Yes.
Isn't it? This was what
Yes,
our
sir.
thing was. So therefore 0 to 2 pi interval can be broken up into two intervals, 0 to pi and pi to 2 pi. So therefore I will now become 1 by 2 pi, first 0 to pi mod sine t dt, and the next is from pi to 2 pi mod sine t dt. Okay, so 1 by 2 pi
Yes, sir.
integral 0 to 2 pi sine t from 0 to 2 pi is simply sine t, and from from pi to 2 pi it is minus sine t dt, right? Any questions?
Yes, sir. No, sir.
So 1 by 2 pi, this is integral sine t is minus cos t. taken between what limits? 0 to pi, plus an integral. You can write this as minus integral pi to 2 pi sin t dt. Okay, so this is 1 by 2 pi, and from minus, if you are taking, so cos t is taken from, now since there's the minus sign, we are making it positive, the limits change, right? So it becomes pi to 0 minus, and sin t becomes cos t, minus cos t in fact. Between the limits pi to 2 pi. Okay, so this is all done. This is 1 by 2 pi. Put the upper limit first. You have cos 0 minus cos pi, right? And this minus sign comes out. It becomes plus cos pi, cos t, sorry, cos t integrated within the limits pi to 2 pi. So this becomes 1 by 2 pi. Cos 0 is 1. And what? How much is cos pi? What is the value of cos pi?
It is my
Cos, you can write this as cos pi minus 0. Pi minus 0 is in the second quadrant.
sir.
That means minus cos 0, isn't it?
Sir.
Minus cos 0
Okay, yes,
plus cos 2 pi minus cos pi. So this is again 1 by 2 pi. 1 cos 0 is 1. Cos 0 is also, cos 0 is 1. So this becomes minus 1. And what is the value of cos pi? Cos 2 pi? It's cos 2 pi minus 0. That means simply cos 0, right? And again cos pi is minus 1.
yes, sir.
So this becomes 1 by 2 pi.
Yes, sir.
1 plus 1 plus 1 plus 1. That means 4 by 2 pi. That means 2 by pi. So that is your answer. Clear with this problem? Or any question?
Clear.
No problem?
Sir, clear.
Okay. Let us move on to the next problem. The problem here is integral evaluate integral minus pi by 2 to plus pi by 2 fx dx, where fx is defined as sine of mod x plus cos of mod x. Okay, this is your problem. So I say let I is equal to integral minus pi by 2 to plus pi by 2 fx dx is equal to, or before this, now see sine mod x plus cos mod x, where fx is equal to Sin mod x plus cos mod x. Right? Now see, here fx is what? See the limits, minus pi by 2 to plus pi by 2. When you see minus a to plus a kind of limit, what comes to your mind? Even function and odd function, right? So we check whether fx is an even function or an odd function. So here f minus x is equal to sine of minus mod x plus cos of this, right? Which is equal to some mod of minus x is what? Mod of minus x is simply mod x plus cos of minus mod x is again simply mod x. That means is equal to fx. That means what? That means fx is an even function. Yes. So what does this integral become? What does this integral become? Therefore, I is equal to twice integral 0
Sir,
to pi by 2. Twice integral 0 to a. Yes. Tell me.
okay.
If you remember this rule, here, you see, property number 1, minus a to plus a twice integral 0 to pi fx, where fx is an even function, right?
Yes, sir.
So we've used that only.
Yes, sir.
So therefore, twice integral 0 to pi fx dx.
Is equal to
Yes, what happened? Yes, tell me. You have any question? Put the value of fx, sin mod x plus cos mod x dx. Separate twice integral 0 to pi by 2 sin mod x dx plus integral 0 to pi by 2.
Yes, sir.
You have any question?
No, sir.
Okay, so
Sir,
this,
that time I'm seeing the properties.
okay. Now 0 to pi by 2 mod x. In between this interval 0 to pi by 2, what is mod x? X is positive in this interval, right? X is in the first
Yes, sir.
quadrant.
Yes, sir.
That means I can write this as 0 to pi by 2 simply sin x. I can remove the mod because x is positive between 0 to pi by 2. In fact, sin x is positive between 0 to pi by 2 because it is in the first quadrant. Similarly, 0 to pi by 2, cos is also positive in the first quadrant, dx. Okay,
Yes,
so
sir.
this is twice integral sin x is minus cos x, evaluated between 0 to 2 pi, and integral sin x is cos x is sin x, evaluated between 0 to pi by 2. That's it. So now
Yes, sir.
this is
Yes.
twice cos x evaluated between pi by 2 to 0 because I've removed the negative sign, plus sin x evaluated between 0 to pi by 2 is equal to twice, this is cos 0 minus cos pi by 2. Upper and the lower limit put in cos, plus again put the upper limit and the lower limit sin pi by 2 minus sin 0 by the fundamental theorem. That is twice cos 0 is 1, cos pi by 2 is 0, plus sin pi by 2 is 0, and sin 0 is also 0. So this is simply 2. Okay,
Yes, sir.
just
Yes, sir.
Mm. Just wait a minute. This is a very important property, which is integral 0 to a fx dx is equal to integral 0 to a f a minus x dx. Now we are going to see some applications of this property. Okay, now this every year, as I told you, every year one problem is given on this property.
Okay, sir.
So let us start with a very simple problem from this property and a very famous problem also. In fact, when you are doing definite integrals, you will definitely come across this sum everywhere. The question is, evaluate this integral. And learn this technique because we are going to use this technique over and over again. 0 to pi by 2 root sin x by root sin x plus cos x plus root cos x dx. Okay, very famous problem. Now look at this very carefully. So we have I is equal to integral 0 to pi by 2 root sin x divided by root sin x plus cos x root cos x dx. Now from this property, what can we write? We can write this as integral 0 to pi by 2 check, okay, root sin pi by 2. A here is pi by 2. Check whether we can write this. Can we write this from this property?
Yes, sir.
Yes, tell me.
Yes, sir.
Okay.
Sir. Yes, sir.
So this now transforms to root sin pi by 2 minus x is nothing but root cos x. And this is root cos x plus root cos pi by 2 minus x is root sin x. So what do we see? I is equal to this and I is also equal to this. Therefore, what can we write? Therefore, I plus I, if I add up I plus I. For the first I, we write this. Integral 0 to pi by 2. Root sin x by root sin x plus cos x. That's root cos x dx. And there's a dx here also. Okay. And for the second integral, we write this. Integral 0 to pi by 2. This is a very important technique. Root cos x divided by root cos x plus root sin x dx. Now, if we combine these two integrals, then what will you get? 0 to pi by 2 root sin x plus root cos x divided by root cos x plus root sin x dx. Are we going to get this or not if we combine?
Yes, sir.
Yes, sir.
Then what will happen? This and this will cancel. You're only going to get integral 0 to pi by 2
Pi
dx,
by 2 dx.
which is nothing but x evaluated between 0 to pi by 2, which is
Yes,
pi
sir.
by 2 minus 0, which is simply pi by 2. But the problem is we have got I plus I is equal to pi by 2. Therefore, 2I is equal to pi by 2, right?
Yes, sir.
Yes, sir.
That means what is I? pi by,
I is pi.
that means
Pi by 4. Yes, sir.
integral 0 to pi by 2, the given integral root cos x divided by root sin x plus root cos x dx is equal to pi by 4. That is your answer. Okay, just one more sum and we'll finish for today because I have class 11 also.
Okay, sir.
Okay, sir.
Problem. Mm, let's do this. Integral 0 to pi by 2 dx by 1 plus cot x. This. Okay. So in this integral, what can we write? First, convert cot x to
Yes.
sin x by cos x. One plus sin x by cos x, and then if you take the LCM, you will get cos x dx by sin x plus cos x. Right?
Yes, sir.
Now we again use the property. Integral 0 to pi by 2, I can write this as cos pi by 2 minus x dx divided by sin pi by 2 minus x plus cos pi by 2 minus x. I can write this way from the property.
Yes, sir. Yes, sir.
That means we get integral 0 to pi by 2. In the numerator, we are going to get sin x divided by, in the denominator, we are going to get cos x plus sin x dx. So I is equal to this, and in fact, I is equal to, not this, I is equal to, I is equal to this, and I is also equal to this. Therefore, what is I plus I?
Sir,
Integral
2i. Yes, sir.
0 to pi by 2 cos x dx divided by sin x plus cos x plus
Yes, sir.
integral 0 to pi by 2 sin x dx divided by cos x plus sin x, or sin x plus cos x, whatever. Now you combine these two, 0 to pi by 2 cos x plus sin x divided by cos x plus sin x dx. What happens? This and this cancel out. So what do we get? Simply integral 0 to pi by 2 integral dx we get. That means this is x evaluated between 0 to pi by 2, which is again simply pi by 2. Pi by 2 minus 0, which is pi by 2. Therefore, 2i is pi by 2. That means I is pi by 4. And what is I? Integral 0 to pi by 2 dx by 1 plus cot x is equal to pi by 4. That's it. Clear with this problem? Do we have time for one more?
Yes, sir.
Yes, sir.
Yes, sir.
No, I don't think I have time for one. So I'll stop here for today.